let's send out notifications. Let me also drop it here. Boom, that's Twitter covered, Discord covered, and let's send it on my Telegram. Most people don't join from there, I think. But yeah, that's all the notifications covered. Let me pull up my secondary monitor so that I know streams are working properly. That looks fine. Cool. Hey, welcome, Save It here. Welcome. How has your day been? Did you get any sleep yet, or is it still a long day for you? It's still crazy to me that you keep joining me like late into the night. So, but it's much appreciated. And hi, Luke. Welcome. Let me see. There. Okay. Something that Saved here says I work from home on Monday so I can sleep in later. Okay. Well, it's I really appreciate that you choose to spend your time with me. So, thanks for that. I just noticed that I'm wearing my comfy clothes again. I just threw it on today because it was a lazy day and we spent most of the time just at home. So, sorry for not looking spiffy. Something I noticed in the dashboard. I think I can bring this up here. Just like I noticed that it says, oh, thanks for the follow. For Saturday, I think that's a follow, right? Yeah. Save It here follows me. Yeah, okay. See, I can see notifications for follows here. What I don't understand is that it says that people subscribed yesterday. I didn't get a notification. I didn't see it. I don't have a notification. So I really wonder, and the same for like a few days before that. When something like that happens, I really appreciate it. I want to thank people, but I don't even get a notification. So I really wonder what's up with that. So yeah, I have like the activity feed here so that I at least can look back when somebody rates me or does a follow. Ah, thanks for the sub, 9 Mary. Now it's so. So is it then just people that do it outside of when I'm streaming, when I'm not streaming or something? I don't know. So it's really appreciated, 9 Barry. Thanks for the sub. That was not why I was asking this, but I was like, I looking at this and I can't remember somebody even subscribing. So how does it? And it's not in the activity feed. So if anybody streams on Twitch and knows what that could be or what I'm missing, please let me know. Because yeah, I would feel bad if somebody subscribed and I didn't at least thank them, right? Hi Black Eye, welcome. So move this out of the way. Nineberry said, I already subbed a few days ago. This was just posting the message in chat. Okay. So unless people actually click show the notification or something, I won't get notified of who subscribed. Interesting. I didn't know that. So as you subscribe to somebody, you have control over whether they see it or not. Okay. Learn something new. Thanks for letting me know. Okay, so I don't have to worry about it. So if people want me to know, they will press a button, and if they don't want me to know, it's also fine. Okay, cool. It's just it's a rare occurrence for me. So when somebody does it, I really like to say thank you. Amber says, I believe there's a difference between subbing first time or subsequent subs. But the thing is, like, if you look at my notification activity feed, it says it just happened a minute ago, and there are no other subs in here. So that's why I was wondering, like, what's that all about? But yeah, it's not that important. I just wanted to make sure that there isn't something broken or that they changed something that I need to account for, because I set up the notifications thing just for this reason, so that I at least know when something like this happens. But okay, let's see. I actually didn't run the benchmark for day 6, which I was curious about because no, was it day 5? Yeah, because I did this in a different way. I was wondering how that performs. So while we're getting ready, I'll just run this one just because I'm curious how it performs. Day 5, I'm not gonna do day 6 because that will spit out a lot of things. So I will just run this now in the background. Debug start without debugging. Okay. So how was everybody's day today? I saw little bits in the show of your stuff Discord. No bench. I forgot to actually add attributes. So let me do that. I use benchmark.net, so I just have to drop this into the day as well, so that there are markers there, and I name them like this so that the overview clearly shows them. And I should probably also add them to day 0. Let me change my day 0 just so that it works properly, and also change the default multi-line to a multi-line comment like this. So this is a better way to get started. Luke says, once again, an easy day today. Yeah, I saw something like that. So I was wondering, but also a little bit of a spoiler probably, but I saw something about BFS, DFS. So is it, somebody said, well, I will be disappointed if there's no pathfinding this weekend. It's a good thing. It's a nice thing that the Discord is busy. Pathfinding. I don't remember who said it, but there was something in there that somebody said that. Hi Marte, welcome. Nineberry says, AOC was quick solve again, copying code and ideas from earlier years. Then went out catching Pokemon. Do you still play Pokemon Go? I did that in like bursts. When my daughter was born, we had to take her out for walks to calm her down. So that was also around the time that I think Pokemon Go was just released or had a resurgence. So I would just take her out with the tablet and the power bank and just walk around the neighborhood catching Pokemon. So I would do it. I think I did it like 1 or 2 years ago. My wife got back into it, so I was like, okay, let's also do that. And it's quite fun, especially when you have people that you can do gyms with, etc. Like I said, I was expecting pathfinding 2. Oh, you got a blue screen of death on part 2. Oh. So there's a trick there that you have to be smart. Hey, Smap, welcome, welcome. Okay. Okay, I have 128 gigs of RAM, so... But that probably won't be enough if 32 isn't enough as well. But yeah, which is actually a flex nowadays with all the RAM pricing going up. But I guess if I want to build a new computer, I will just split my my memory in half and build 2 64 gig machines. Let's see. Hey, Blowfish. Smap says I'm limited to 64 gigs on my laptop. Yeah, I have two machines with 128 gigs here, so I can, and like in general, I don't use that much RAM, I think. I only have 52 gigs in use right now, but I just recently rebooted, so usually it's a bit higher, but yeah. Even with a bunch of Chrome tabs, usually I'm below, like at or below 64 gigs, so it's fine. I have a little bit of room to grow. Boom, 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 boom. Actually, using memory should never let you do screen of death, though. That's usually a different problem, but yeah, I think we should. Oh yeah, I want it. Already being scatterbrained. Debug. Start without debugging. I wanted to run day 5 to see how fast it was. It's a pain. One more time. I just wanted to see quickly how fast it ran. But the benchmarking also takes like a minute or something, but yeah, we have a bit of time. Maybe I should just start reading day 7 while this runs. Get that over with. So let's zoom this in. Day 7, Laboratories. You thank the cephalopod? I can't remember it. See, I told you yesterday. English. Cephalopods, is it? Right?
Cephalopods.
Cephalopods. Yeah. Just when I go to look it up, it, it says it's cephalopods. Okay. You thank the cephalopods for the help and exit the trash compactor, finding yourself in the familiar halls of a North Pole research wing. Based on the large sign that says Teleporter Hub, they seem to be researching teleportation. You can't help but try it for yourself and step onto the large yellow teleporter pad. Let me turn off the AC because it's probably causing a bunch of wind noise in the back. Didn't think about that. Suddenly you find yourself in an unfamiliar room. The room has no doors. The only way out is the teleporter. Unfortunately, the teleporter seems to be leaking magic smoke. Okay. Since this is a teleporter lab, there are lots of spare parts, manuals and diagnostic equipment lying around. After connecting one of the diagnostic tools, it helpfully displays error code. Oh no! Okay. But those are zeros, right? 0H and 0. But it's funny. Which apparently means that there's an issue with one of the tachyon manifolds. You quickly locate a diagram of the tachyon manifold, your puzzle input. A tachyon beam enters the manifold at the location marked S. Tachyon beams always move downwards. Tachyon beams pass freely through empty space. However, if a tachyon beam encounters a splitter, the beam is stopped. Instead, a new tachyon beam continues from the immediate left and from the immediate right of the splitter. Okay, sure. Yeah, I recall this kind of problem. We did it before. Hey Hunter, welcome, welcome. So this boom, it will cascade, it will fill all of these, sure. In this example, the first incoming tachyon beam extends downwards from S until it reaches the first splitter. At that point, the original beam stops. Sure, we can all follow this. And it will go and go and go and go. To repair the teleporter, you first need to understand the beam splitting properties of the tachyon manifold. In this example, a tachyon beam is split a total of 21 times. Analyze your manifold diagram. How many times will the beam be split? Okay. This is Advent of Code Day 7, Hunter. If you're not familiar with it, it's a daily programming puzzle that starts in December. He says, I found that it's similar to the paper roll picking, like 2 problems ago. Now actually, in previous years, we had something like this that had 2 forms of splitting. So this is very similar to a problem, only now currently it starts at 1 and moves in 1 direction. Yeah, and you can go back if you really like it and do the previous years as well. If you go to the top and click events, you can see all the previous years and still do those as well. So there's lots more to do if you want, and they're really cool. So let's see. So yeah. So let's copy today's output. Let's see. Day 5, part 2 was 22. So let me just drop this before I forget. Put it in the Discord. Bench. Okay. That's that. Let me copy day 0, make it a day 7. Okay. Set everything up for the day. The answer to P1 was 21, if I remember correctly. Let's set the base correctly so that it can parse the input. And let me just also name these. I should make this into a macro that just spits it out, but yeah, that's for later. I've been saying that for like 5 years. Let's see. Save it here says, this is not like the paper picking one, quite different. Yeah, this is like a raycast thing with the splitter. We had that, I think it was last year. But this seems like a a more basic version of that. Let me just put this here. So we can put it like that. Okay, that's the input marked. So we have start marker is S, splitter marker is this. Octonel says, hiya, good day for span 2D. Yeah, but without having to use it, I will probably not use it and just do the stuff that I'm familiar with, but it might be a good day to look into that. I should probably do it at some point. Let's remove all of that stuff. Sure. So we do input dot two lines. No, two lines. So var line. We just can't do this actually. And we do map, and then we do I thought it was map. Yeah, I think it's map all. This will be start marker and splitter marker. So we do and we also have the list grid location splitters. Like this. Okay, this is fine. Var parsed is this, and then I can do var start marker is parsed start marker 0, basically the first one. Oh, I thought I had something that would parse them into different. Let me look at my helper. Smap says, I spent most of the day completely rewriting my 2D grid helpers as I didn't like the way one line looked and my solution may have gone overboard as usual. Well, as long as you're having fun, right? And Octonel says, it took me longer to figure out what the ask was in part 2 than it took to code it, probably because English is not my first language. I actually had to have Copilot explain what was needed. Okay. Hunter asks, I'm not familiar with C#, what are those markers for? What I'm doing right now, this is the input. I'm defining the things that we look for, so that I can refer to them by name instead of having the literals there. And I have some helper code that lets me parse this into a sparse grid. And I think I had a function that spits out hash sets. Yeah, this one. This was the one that I was looking for actually. The map all did it combined. So I do a start marker, and this would be a splitter marker. So, and this would then return a list of this. So then we can do start marker is parsed. In this case, it's the first and the first one of that. First, and then we do var splitters is parsed 1, and this will be the hash set of grid locations. So this is my own helper code in this case. So I have a function that I can feed a list of lines, and it will treat it as a 2D map. And then I can tell, well, I'm not interested in only the things that I feed to you, in this case the start marker and the splitter marker, and it will return a sparse map, like not a full map, but I'll take a list of XY coordinates for where I can find these things. So whenever I deal with this stuff, it's always, I usually go to sparse maps because there's barely any there's hardly a good reason to use the full dimensions because the white space doesn't matter at all. Let's see, maps. The plan is now, now I have my grid class. I can write a sparse grid class to mirror it. Okay, yeah. So this is like a hash set of the locations, and I actually thought that this would spit out grid locations instead of the thing. So let me see, because I have all sorts of different ones. The one that I want to return is actually a thing called grid location, because I have all sorts of operators for that. So if I look at my code here and I go to the types, let's see, here, map as grid location. I should actually just read more. And this grid location is nothing more than the same XY combination, like a row and column value, but it also has simple checks for, is it in bounds? What would I get if I would move one up, or what if I want to do math with them? So this just has helpers to make life easier when dealing with 2D coordinates. And I also wrote this for 3D one year, but I don't know where I have that code, and I didn't extract it to the general library. So yeah, let's go back. Day 7, map as grid locations is the one that I want. And so this will be a hash set of grid location, and that's a type that I prefer when dealing with coordinates, just because I have my own helpers in there. So yeah, this should also be just like a grid location. So I can declare these up top so that it's available for the rest of the class after the initial parse. So I have my start marker and I have my list of splitter, and I can call this splitter locations actually. And this I can call start location. That's better, I think. Okay, so this will be start location, and this will be splitter locations. Okay, so that's the basic input parsed. Now what we need to do is figure out a path traversal, and then count how many times it splits. But every time it splits, it does a new one. So we could have a function or a queue. And I think a queue is just easy, so we can do a queue grid location grid location beams, right? And I can do beams dot and queue start location, and then we do while beams that count, and then we process the queue. So the thing that it needs to do is it needs this one and process it all the way down. So we can do grid location beam. Beam is beams.dq. And then we can do beam is beam.down. And then we can check if splitter location contains beam. Beam dot row larger, actually smaller than max rows. Let's put that in here as well. Do int max rows, and max rows becomes map.length. So these are the rows. So we can do while this one, while beam the row is smaller than that one, and I need to check if I don't get an off by 1 for that. just to make sure, because we can't go down. Yeah, I think this is correct. So this one will probably, it should probably be a do while loop, right? So this would be do and do while blah. And this one would break. We would increment P1 and we would enqueue 2 more. So what we would do is, I think it's like 1 to the left, 1 to the right, okay? This one, is it 1 or 2 off? So no, it stops the 2 being emitted from the splitter. They exist at the sides there. So what happens if this one hits another splitter right next to it? Is the thing that I would be curious about. Let's see, the way it's reasoned. Blah, 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 blah. Tachyon pass freely to empty space. However, if a tachyon beam encounters a splitter, the beam is stopped. Instead, a new tachyon beam can... Okay. The way this is worded, I don't think there can be 2 next to each other, because it would infinitely loop and create more. So the input should probably not have any 2 of these next to each other, but I will validate that in a bit. So for now, let's see. Yeah, I guess that's not allowed. Yeah. I'll just not account for it now, but that means like the ones that are spawned don't check their current location only after they're moved down, so that is fine. So we do beams.enqueue, beam.left, and beam.right. Now the thing is, if these are out of bounds, we should probably stop, and in part 2 probably they will just wrap around or something. So I should probably check. So I could do far left is this, right is beam.right. Come on, grid location. Let me also check if this just creates a new one or if this updates the current one. This one will create a new one and not update the current one, so that is great. That's exactly what we want. If left dot column, I can actually do is inbound, but we don't matter. Dot column larger than 0. Boom. Left. Let's also do macros max call. Max call is map 0 length. Okay, so here we do if right.column is smaller than max call, and then we enqueue right. Okay, so this should basically be part 1. So let's update the solution, no, not the solution, the program to run day 7. And let's see if this works. 39, that's not correct, right? Because it should have been 21, I think. 21 times, great. Off by 18, yeah. Let's see. That's interesting. Didn't expect that, to be honest. Let's see. Remember duplicate be, yeah, I know. I only, oh wait, no, yeah, that's what I do here. When I hit a splitter, I increment, so. But these ones, I probably have to deduplicate them or something. So that's the issue here. But that shouldn't matter. Yeah, but the thing is, like this one produces 3 beams, but I would process this one twice. So that's one of the issues. So what I can do is I can do hash set grid location unique constraint is blah. Boom, 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 boom. And I can do start location there. Come on. And this only should happen per level, so I probably don't need to do it this rigorously, but it's fine. So if I run it now, it probably works. 22, off by 1 still. Interesting. The vacuum beam is split a total of 21 times. Let me think. No, actually, no. What I said is, what I did was like, if you look what happens here, let me see, I can show you. It goes down here. When it hits something, it creates these two. When these two go down, it will create the same one at this place. So what I do is make sure that I do this beam only once instead of twice. So basically what it does, shouldn't you just count these dashes like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So is there one that isn't hit in the end? Is that the issue? Like this one doesn't have one on top of it. So this one doesn't get hit. So that's interesting. So if you look at the drawing, it's basically you can never have more than these count, right? Because these are the ones that exist. So in this case, all of them except one are hit, which is this one. But for some reason, mine split 22 times. That is weird. So what I can do is grid location, hash set grid location new beams. Whoop. So I can do this. So I can draw it out now. So I can do for int I is 0, I smaller than max goal increment I. So this would actually be row for int call is 0, call smaller. So let me just draw out everything that I've done so far and make sure that I see what's happening. So I can do console right line, boom. Actually, I can just do an empty right line here because this will be the end marker there. My input is properly aligned, right? So that's not the issue. Yeah, it's just a code thing then. So I messed up somewhere. So grid location current. I think that's the one, right? I have operators. Row call. Yeah, I do it row call. Sure. So let's see what's happening here. So I can do if current equals start location. No, start location. Console.write. Let me see. Char m. So this will be the marker to draw. M is start marker. Else if splitter locations contains current. M equals split marker, sure. Else if added, how did I call them? New beams, sorry. New beams, M is this, else M equals period, like this, okay. That contains current, okay. So here we do console.write M. Okay, so if we run this now, it will print out the map that we've made. Okay, so clearly it doesn't show that one there, so that is good. So it added these two here, it added these, it added these. Like this end result seems to be correct if you ask me. It didn't do one on this side here. That's interesting. So that's my column. My bad. Let me run this again. It now should show on the left side as well. Okay, so now that's another bug taken care of. So you can tell this one is the only one that didn't get hit, so that's cool. So I wonder why this one hits more than once. So let's do list grid location hit locations location. Boom. Boom. If contains current console set foreground color is color green, else very inefficient but this works, is white. Okay, so let's visualize what's going on there. And I should probably also set a breakpoint so that I need to make sure that okay, you can see here that it visualized every one of them except this one, so it's working as expected, except we count 22. So we need to know why something is counted double, which is very interesting to me. Which also means, like in this hit location, there should be a duplicate value there. So let's see, hit locations, quick watch. And I could use code to figure out which one it is. And I should probably use code to figure it out because I don't spot it right away. These are all unique values. Wait. 1, 2, 3, 4. Okay, there are 21 light up green, but there are 22 in here. Am I so blind? Okay, let me see. So there is a duplicate one in there, and I didn't spot it. So let me see. Sure. So we do hit locations group. Where okay, I probably can't do this because it will complain. Yeah, was afraid of that. So let's run this again. Could probably frequency count and then do a different color for the dupe so that we can see it in there. But okay, dude, to dictionary. So let's do that. This, and now I can do a frequency try get value current out int hits. Come on. Wait. Yeah, sure. I need to do this x, comma x, count like this. So this should now be a dictionary of grid location int. A grouping of grid location. Oh, yeah, I need the key. Come on. Okay. And now if hits equals 1, we do this. Else we do red. Okay, now we visualize the problem. Visual Studio is really. Ah, yeah, I did that for the bench. Good point. Let's see. So it counted this one twice. And I wonder why that is. Because it can arrive there at multiple points, and yeah, because we need to count the splits. If it hits the same point more than once, it doesn't matter. So we also need to take care of that. And so actually what I needed to do was not record the hit locations. Well, I can do that to just do less work because you would queue doubles. I should actually make sure that the hit location wasn't processed yet, because like it's determined. I'm not sure if that's the right term, but the result of any one of these splitters getting hit is there will be two besides them. And the path that it follows is always the same. So hitting it more than once doesn't change anything. So we only need to count the first time that it's hit there. So that makes sense. So this hit locations that I had here was actually great. Like this. And now this is the full logic and it should work. It's nice that like debugging it makes you think through and see all the problems, and all of this wasn't clear to me while reading the problem set itself, so that's good. So yeah, I'm not sure if that's a good puzzle design or not, but like the full set of things that I have to do weren't clear to me when I read the problem, and that's largely on me, but probably also a small part on the problem set itself. Did anybody else have that issue as well, or is it just me and I shouldn't complain? Let's see. I should probably not write out this whole thing, but... So here we have our full marker, and now we can also tell which ones are not hit, etc. That's fun. Maybe it'll be of use in part 2 or something. Oh, my answer is too high. Wait, that's interesting. My answer is too high? How is that possible? Okay, so I probably didn't understand part of the problem set again. Too high. Okay, interesting. Save it here says, nah, AOC problem description was always terrible. Okay. So I can do this into debug mode. Not that that will change anything, but this is weird. Because that means that I'm still doing something wrong. I wonder if by just looking at it, I can see something wrong here. Amate says, damn, I was getting ready with the stars. Yeah, I can imagine. I also don't see what the issue is right now. A few are white. Yeah, that's true. A few can be white because not everything has to be hit. Like this one here. Smap says, I can see what's wrong with your diagram. Okay. Okay. I don't print all the ways down, right? Like what my code does is at a split, it will do these and only do them once. It won't queue them more than once, and it will only process a hit like this only once. Smap says, I can see some green that is right above another green, so that is incorrect. That doesn't have to be incorrect because it can be there, right? I mean, the logic itself is so basic that I wonder what could be wrong. Spam says, I can see a period missing at the end of at least one line. That can't be right. Is it a wrapping thing maybe? Because, oh, that is weird. That would mean there's a bug in the input file, which is automatically downloaded. So let's see. Let's run it in debug again. That will automatically download the file again. So maybe that's part of the issue. Let me see. Now the period isn't there. So that's interesting. I get the exact same answer though, so it might be an issue somewhere, but I wonder now if my release file was bugged. Let's see. Let me switch over because I need to move some stuff and I can't show client things. So let me just open Notepad and drag one of them here. No worries. Okay. Usually it opens to my other desktop and I have client stuff open there that I can't show. So let me see. Open. Bin release.net cache day 7. Okay, like this is cache day 7. Okay, it must be a fluke somewhere with the code because there's not a period missing here either way. So it's weird that there was a period there missing, but okay, that's not it. Let's see, did the first one give you 21? Yes, my code, I can run it back and go to test is true. And the first one, part 1 is 21, and it has a tree here, and it works. So, hit locations, like this is all the same. So I wonder why it says it's too high, because I calculated that these would be the locations that are hit. Thanks for the follow, low level RS. Welcome. I'm really curious to see how many splitters are there even. Splitter locations. There are 1766 of them. Let's see. Which means Eric has got you with something you misunderstood in the description. Time to reread it. Okay. Save it here says there's something wrong in the logic. Some of the green carrots are incorrect. Yeah, apparently. But the logic that I follow is like I take the beam and once it hits a splitter, it stops existing. And it spawns these ones to the side and these all traverse down for as far as they can. Which is like, I wouldn't know how that could be wrong. So for me, like this one doesn't get hit and this one doesn't get hit, but apparently there should be more that don't get hit. And I didn't see any more logic following here. It's like it's split. They pass freely through. Wait, I think I know. No, that's not it. They pass freely through empty space. Oh yeah, and when they hit a splitter that they've seen before, they need to stop existing. Yeah, that's the thing that I didn't. Yeah, I understand it too. And that's because I deduplicate stuff here as well. Like the logic here, this one needs to be inside here. This is the part that I'm doing wrong. So I only need to count it, but I do need to stop processing it once I've hit a splitter. So that's my mistake. I'll show you by running it again. Damn it, slow. So now the answer is 1656, and this is probably correct. So I realized the issue, I think. Let's see. Woohoo! Okay, glad I caught that fairly quickly. Thanks for the gold star, appreciate it. Sorry that it took this long, but yeah. Okay, so did everybody catch my mistake as well? Do I need to explain again? I think it was fairly clear, right? Thank you for the... That's a nice looking star, Hunter. Let's see. Part 2. With your analysis of the manifold complete, you begin fixing the teleporter. However, as you open the side of the teleporter to replace the broken manifold, you're surprised to discover that it isn't a classical tachyon manifold, it's a quantum tachyon manifold. With a quantum tachyon manifold, only a single tachyon's particle is sent through the manifold. A tachyon particle takes both the left and the right path of each splitter encountered. Okay? Since this is impossible, the manual recommends the many worlds interpretation of quantum tachyon splitting. Each time a particle reaches a splitter, it's actually time itself which splits. In one timeline, the particle went left, and the other timeline, the particle went right. To fix the manifold, what you really need to know is the number of timelines active after a single particle completes all of its possible journeys through the manifold. In the above example, there are many timelines. For instance, there's the timeline, yeah, sure, always left. Okay. Isn't this just like the power of 2 for every one that you hit? Dun, 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 dun. 40 timelines. Apply the manual interpretation. How many different timelines would a single tachyon particle end up on? Wait. Let me think. Like if the number just, I think it just doubles on every one that you hit. So let's see. I haven't tried this yet, but yeah, I think there's also something with powers. Yeah, like in my mind, but they say 40 here. So this will be 2. This will be way more than that. It's actually like the unique way. No, that's not correct. It's the unique ways to get here actually in the end path, right? It's 1, 2, 3, 4, 5, 6, except it's 5 because not all of them got hit. Let me go back to the test case. Let me input the actual answer here. Answer part 1 equals this. Let's go back to the test case. Part 2 was 40. I actually think if we look back to like the colored map, I think it would be 1, 2, 3, 4, 5. Isn't it? No, that also doesn't work. It's 4, 12. No. Actually, that was my thought too, but I couldn't get that to work. Yeah, because like for all of these, it would be too many. But I'm just thinking, like, even if you count the unique, like these are all the unique things that happen, and even if you start multiplying there, it's too much. But like this whole left line is 1, and then you get 2, and then 3, 4. So basically, if I do this and then work my path to find all the unique paths, I think that's like this is part of the solution, this matrix here, because these are all the paths taken in the end. So if you then backtrack from this one and find all the unique ways to get back up, you would have your answer. I think like this left path is 1, this one becomes 2, and then this one is exhausted, so you get 3, 4, and then this path is exhausted, and then you get 5, 6. I think like this is the answer, to just find your way back and count those. So in my mind, like the end result or the data that I tracked for part 1 is the start of part 2. But how do I actually code that? Am I crazy? I'm just trying to think, because like I already have these values here. Blop. Come on. So I think actually this is the thing that I need to do. I'm just trying to think of how to actually do it, because from this one I need to look like, is there like 2 up and then 1 to the right or left? Is there a beam that I can hop onto? Um, mm, 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 mm. So I think I should actually do it like this, and then I have it like this, and then part 2 would just be to traverse this one in reverse. Let's see, int last row. do we have any dead ends? No, that's not true because uh, hmm. I'm just thinking like there can be more than just the single hop distance here. Let's see. Luke says, I saw multiple solutions going up. I did the same kind of thing as P1. Yeah, I can understand that, but mm, 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 mm. Hey, Mizzy. I'm fine. I did part one, and I wrote. I had lots of stuff that I didn't account for. Like I didn't deduplicate my beams. Uh, then I was smart enough to not hit the same thing once, but then I didn't stop processing that beam once it hit it a second time. So after I worked all of that out, I got my part one, and now I'm just thinking of how to do part two. And like when I visualize it, I can reason about how I would do part two, because like all these pipes characters here, I can just count back the unique ways to go back up. But I don't have the relation between these two, and in the real input, the distance between these can be more than just one set of lines. So it will be harder to deduce which is an actual path. So I would have to record extra data with the traversal there to probably write unique paths. Uh, and like in my mind, there should be a fairly easy way to do this, but I'm getting a bit stumped in trying how to go about this. Mm. Mm. Let me think. Luke says, if you need the name of the algorithm, just say, hey, no, no, no. I'm just trying to think like, there, what do you call it? If I would explore all the options myself, it would take too long. I'm just trying to think, okay, what are the options there? Um, like I'm thinking, if is there enough information there to calculate it? Calculate quantum timelines. Yes, yes, yes. Um, like I feel from this one, I could do it by just drawing lines and do it by hand and just crossing things out, and then I could follow this up. I'm just thinking like the connection between this one and this one isn't tracked in my current code, so I would have to do like for everywhere that I got, I would have to record that one, how I got there. But I deduplicate stuff like this. So for these two, this one is only recorded once. So the second time that I get here, I don't add this one. So I should probably record, even though I don't follow it here, I should probably still record that I would be able to get here from here. I wonder if I do that, if there's like a number in the bottom that I can add up, if I take all of that into account. Let me see. Yeah, called Time Traveler. Yeah. Boom, 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 boom. So, if we start out with this, sure, this is B2, but we don't care. Would we, for every location, because this is like everything we, this is the unique constraint thing here. So I could turn this into a dictionary, and this would be a hash set, grid location, and this would be the way via how we got there. Come on. Basically, we got there because we started there. So here we need to do if try get value paths else. Boom. Let's see. Lineberry says solutions to travel back in time and prevent Henry from creating the puzzle. Yeah, sure. Let's see. We have the paths, 5 paths. Paths of add, and this would be beam. Beam. Like this. Same thing here. So this would tell us then for each one of these how we could get there. So now when we visualize we would actually take a unique constraint instead of new beams. So we do if, no, that's not what I wanted. Try to get value current out var ways, and then we do m is ways to string 0, and this will bite me in the behind because this one can be more than 10 or more than 9, and then it will show. But let me do this for the test case now and see if that helps my mental gymnastics to see if I can deduce more from that. Let's remove the breakpoint. Boom. That's okay. Interesting. And not correct. Because I need to take into account the parent count as well for the thing and work it all the way back. It's interesting because this is just not correct. Actually, yeah, no. I think it should be impossible to get 2 here because there can't be 2 there. It's really weird. Let me just say, boom. Wait, what? Never mind. This is stupid. This is unique constraints, and this is dot. Sorry, my bad. I was printing out the wrong thing there. And I'm trying to remove my breakpoint. Okay, this makes more sense. Okay, this was what I was looking for. Like, here, there's 2 ways to get here. And now the thing that we should do is probably keep track of this and increment it here. And then you count up in the end the sum of these, and then you should have your answer, I think. But then you need to know how you got there. Let me think. Int recursive count. Grid location. Look. Okay, let's see. While no. Is that data not available here? Okay. Then I'll just make it a local function just for this case. Yes, I will return the value. Int result is 0. Return result. Bum, 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 bum. Let me think. for each way in ways. So this would be result plus equal ways of count. And then we do result plus equal recursive count way, actually, way. Let's see if this breaks everything. Now I have an infinite loop. Let's see. Location is 2726. Yeah, okay. This should only go up. Why? Oh, this is. I'm an idiot. Never mind. My idea was to update loc and then. Never mind. This is just a brain fart. This is if. Okay. Because I will know this will Stack Overflow once I get to the real input. I just want to do this as a proof of concept. But I was like, maybe I can write it as a while loop, but it branches, so I have to write a queue there. So I just wanted to do this, and it didn't work as I expected. Why didn't it work as expected? Because I expect this last one here to be able to traverse all of these and just add it up. Because this one got from here and then... What am I missing there? So like one of this, the last one here, like 14, 14. It has 14, 13 in it, but okay, that refers to the beam and not the thing that got there. So I think there is a viable way to do it that way, but I'm not tracking enough data or recording enough data yet, because I need to have like the path info for every one of them. Because basically what I want to do is just be able to tell how many ways you can have to get there. Let me see. And I've written pathfinding things before, so I wonder why my head is struggling in a way that I am right now. Maybe I'm thinking too complicated about this. Let me think. Because pathfinding doesn't count, it's different. Well, yes and no. It's still like unique paths where you fork every time. I think, didn't we do something with finding unique paths before? Isn't it like... Hmm. Um, Let me think. Because I have like large parts of the problem I have. I already have which ones will be visited. Then you just need to know from which one can you get to which other ones. Um, and then it should be like just multiplying it, right? Let me think. Um, hmm. Because in my mind, you basically you have to find all the unique combinations. And that's not that difficult, yet I'm finding it difficult to come up with a plan to code. Um, Let me just, by the way, just commit for day. Where is my GitHub desktop? Let me just put this on Git while I fumble about a bit more. Day 7, part 1. Let me just put that there and push it. Because I think I want to erase all of this for now and just come up with something new. Because you will have like a unique path is just a set of locations that you've hit. So I wonder if I need to like find the unique ways to get to the bottom. Record connections between splitters. Let's see. Because if we've done something, you don't need to do it again. I'm just thinking like there's a... Do I have the test case on? Yes, okay. Like there is ways to cache parts of this. Like if you hit this, you know there's only a certain certain parts that you do next. No matter how you get there, you know once you hit here, there are these many options to the end. So we can cache those working up. I'm just thinking about, something tells me I need to go back to front here. Because we can, or we need to go deep once and then have it cached. Yeah, I'm just trying to think about what to do there. I'm just gonna grab a screenshot so I can just keep this on my screen here. Bloop. So that I don't have to run it every time, just as a visual aid to think about it. So let's see, if we would have like a priority queue thing where we would navigate this. Let's see, what is this? Sure. Don't even remember this. Let me grab a reference because I've used this before. This is the value there, sure. Yeah, it doesn't matter. I can just put in what I want to track here and then int, and then it's fine. Or long queue. Okay, so what do we want to know? We want to know grid location position, a hash set grid location. Actually, it can be a visited. This will also be our path, though not in a certain order. Long is a good idea, yeah. Let me think. What do we want? I'm still trying to think like, how do we record the thing that we need? Because we need to know, if I go back to this, I want to keep track of like, if we get up here, well, I don't want to draw on this. If we get up to this point, we know that there are two more down, but how do I encode that in this thing as well? So you would have like a dictionary of grid location and then a hash set of grid location next levels. So what we could do is record from this one, okay, you can reach this one and this one directly on the next level. And I think we could use that and reverse it and build that up maybe. But that's also something we can deduce from having this one. If we do this as a, like, you do the visited for the efficiency, does that matter there? We can do like a list of this with path. So every step between one of these would be an A/B connection. And something tells me that I need to work my way back from the end positions here. But then again, I don't know what end positions are because they don't have to occur on the last row. So what I should probably do is like in the logic for part 1 that I do, where I basically map out all of this and find out every one of them that I can reach. I should keep keep track of the path that we took to get there, and then but that doesn't have all the unique paths. But that would give me like the final stage of each one of them, like every everyone that doesn't get any new ones and just dies, like in the part 1 logic. If we go here and like if we do this one, if we hit and we haven't seen it before, like at this point we could boom, 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 boom. It will keep looping here till we get to the end. So we could, once we hit, we exit here, we could record the last one that it would see. If it goes out of scope here. But that might not be very good idea. What was a very good idea? Because I've been saying so many things. And I feel kind of lost right now, to be honest. Because I've got concepts of an idea, but okay, just the long part. Okay, yeah, okay. And the back of my mind is going like, everybody thought it was fairly easy. Why? It's so funny that I'm struggling with this now when everybody else says, "Oh, I thought that was easy." I actually wonder if I would take the part 1 code. Let's just go back and take the part 1 code. If I would remove all of the stuff that checks it. Like all of these, if it doesn't contain it. Basically all of this, how long it would run. Smap says it's one of those where if you pick the right idea, the code is trivial. Oh yeah, for sure. But that's true for lots of things. Like if I just do the stupid thing and let all of them run, I wonder how long it would run. So just not doing anything. Luke says the fact that you need long is a tiny hint that brute force might not be the best answer. Okay. No, I know. But still, without doing any optimization here, and just taking all the branches, I removed all the deduplication stuff that I did here, right? I would, and I didn't, like if it would result in duplicate things, it would still just add it to the queue and run it. So what is the difficult? I'm missing something, I think. But let's see if I make this queue a bit harder. So let me see. And I notice I really need that visual aid just to keep my mind on it. Do I still have it in the notifications here? Nope, I just run it again. Okay. You need to know all the unique ways to get there, basically. Hunter says, how difficult is this for these problems? I'm not sure I understand the question, but almost everybody in my Discord solved it and thought today was a fairly easy day, but for me it's tough today. So, but I don't really understand the question. So maybe you can rephrase it in a different way. How do I even record this? Because I could cue something like this is pause, and I can do grid location previous. So I could do that. Do I need to know anything else? Or if I just do null here, who cares? Then I can do hash set grid location from grid location to connections is this. Hunter says, he says, oh, it's not unusually difficult then. No, it's not, but I'm struggling with it anyways. So for me it's difficult, but for the other people that knew exactly what to do here, it was fairly trivial. But that's like any problem that you know how to solve is no longer a difficult problem, right? I'm just trying to figure out how I'm going to do this. So for now, I'm just gonna write some code that will record the last splitter that I went through and then connect two of those and then see if I can get all the unique combinations so that at least we'll make a map from how you can get from one to another. And then I can maybe chain those together, get all the permutations there or something. I don't know. But it sounds like I'm not going to get there anytime soon. So bear with me if you can. Let's see. Marta says that would be the second time Discord says it's easy and you're struggling a bit. Coincidence? No, that's just my lack of skill, probably. And everybody has their own things that they're good at, but yeah, this is clearly a problem that I'm not well versed at solving. So let me see. So beam. This would be current. So grid location. Current. Like this. Beam current. So we would do this, comma, beam the so this one wouldn't change because we're just moving, we don't change the recording there. Something like this. Now we do comma. Smap says he find pathfinding easy. I really struggle with that. Yeah. Yeah, everybody has stuff that they're easier, that they find easier, but yeah. I'm trying to keep my train of thought going, but it's like not really working well because let me see. Oh yeah, this would be actually beam dot current would be the previous hit for this one. So we enqueue this beam and this one would be the last one that they hit. So at this point, like the combination would be connections.add, and this would be like beam.current, actually beam.current, beam.previous. This would be a connection between two hit points. And this one will automatically deduplicate itself, but that should be fine. So this will tell us how we can get from one to another, which is, it's fairly trivial, but still there can be multiple levels between them. So we build this path up. Same thing here, like that. Okay. So if we run this, let me set a breakpoint here. No connections. Wait, what? What happened? Let me see. This is interesting. So now it did nothing. Okay. Never mind, that one needed to be there. That explains why it didn't work. So let's run this. Okay, so it's liking this a whole lot less already. How big is the queue? Okay. So the deduplication does do a lot. Okay. So in my test before, it was skewed because I had the break in the wrong spot, so it made me think that I didn't need all the logic from part 1, but I do. Okay. Okay. So now the question is, how do I... Since I basically have... something tells me that I have all the information that I need. I just need to put it together. Because the code from part 1, I think I get everything there. So why am I struggling so much? Part 2, grid location beams. Let's see. While we do the traversal, I'm just wondering, like, if we keep track of the path, because something tells me, like, my mind keeps telling me, this is what we need, this data, and then using this you need to work backwards so that you can cache all the things there. Because every time you arrive here, like, the path down is always the same. But let's see, there's lots of inspiration to take from posts on the AOC sub. Yeah, the thing is, there's the actual solutions are there. People implemented in code. I can go to my own Discord and, like, all the people here in chat, they have posted how they solved it today, right? So day 7, I can go in and look at the code right now. That's not the issue. The thing is, I'm trying to figure it out myself. Who was the first to post it today? That would be Save It Here, I think is the name on Twitch for him. So yeah, code is there. Oh, I like animations. Okay. I haven't been to the Reddit this year, all year actually. Nightberry says there are multiple different approaches I have seen. Yeah, I'm just like, I'm trying to wrap my head around it and how to do it, and I can't pick a approach from for the life of me. because I can do, like, my thinking is, once you go, if you do it in reverse, and then go down, is that the way? No. Because like in my mind, if you do the unique paths, the only way you can get cache data is like the point from this here down, or from this here down. The results will always be the same going from here. So my idea is that however you end up here, left or right, once you get here, you know all the possible ways down. And so you can cache that. And I wonder if, like, if I start from here, how do I know that I've exhausted it, all the options? So I think you need to go down once, and then go back up, and then fill. But how do you know that you've found all of them? Is when you... Hmm. So that's what my mind can't figure out. Like, okay, what would be the way to do this properly? And I'm really stuck on it. And like every time I look at it, I'm like, the answer is staring you right in the face. Why can't you take the next step? And that's really annoying. Because I've already solved the problem basically. I can tell which ones will be hit, which ones won't get hit. I should be able to tell all the connections between them. Blowfish Fugu says, I just see a tree. Yeah. Yeah, but basically, all the green ones are the splitters that we hit. The white ones are the ones we don't hit. And these are the unique beams that form from there, for every one of these. So what we should map out is the unique ways to get from one to another. All the unique ways. And I'm thinking of how can we do it without actually do it, and just cache all of the paths there. Mm. Boom, 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 boom. So for part one, what we did was deduplicate out all of the stuff that would cause branches. This must be really boring to look at, just me like going in circles and being stumped with what to do next. Like there's no coding, there's just me copy pasting the same thing, making edits, going back, making edits, going back. At what point do I just say, okay, I give up and just move on? Because I don't think this is much fun for anybody. Or do you enjoy this? Because even for part one, I have so much extra data that I probably don't need just to visualize and get it all there. Schadenfreude, yeah, yeah, that's true. Matt says the thought process is interesting, at least for me. Okay. Yeah, but like I'm getting frustrated at myself because I can like I would be able to just take the output and probably I just need to find a way to actually turn it into code, which is my problem. And that's why I keep going back to this, because it's like the answer is staring me right at the face. Like, Black Guy says, I agree, I went through the same seeking computer dying. Wait, what? An answer to, let's see what this is an answer to. I'm missing something, I think. No? Ah, I just see a tree. Ah, okay, yeah. I went through the same seeing computer dying with a million elements queue. Okay. Like, because the answer to the solution, I should probably go back to the test, because that's easier to show, and probably also easier to work and test the assumptions on. True. Like this whole thing is one result, one path, and then we go to here, and then it's another one. So every time you hit here, and maybe I should take this one as a better example. We know that if you reach here, there are 2 more paths down. If you reach this level, there will be 2 here, and these branch off. So it doesn't matter if you get to here from here or you get to here from here. Once you hit here, the amount of forks that will happen is always the same going down. So once you get here, you can just plus the amount of forks that this would generate for every unique way that you can get here. And I think you can roll that way all the way up. So like if you get here, the unique, it would be the sum of this and this times 2, a plus, yeah, 1 there, 1 there. And I remember doing something like this previously, but it just doesn't click completely. Luke says, why not start at the top and just count? Yeah. Because I don't process all of them. So I don't know how to count them right now. What does it do? You have to process all of them. No, just the variance. Pascal is a good hint. I don't know. No, I really don't know how to go about this right now. Marta says, maybe don't look at the bottom row, start from the top to see what data you can get there. Yeah, but sure, why not? And it probably doesn't even need to be a priority queue, because Bum, 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 bum. Current, and then we can do list, grid location, path. But I don't know how this would help. Would it? The thing is, I actually don't know what I would do here, because I don't know. Yeah, if I hit the max row, that would be fine. Let's see, if beam.row equals max rows, reach the bottom. But what does that tell me? Because I've coded it in a way that I don't do stuff more than once, so I won't have unique paths to go back to, due to the way it's coded right now and deduplicated. So once I remove all of those protections, I run into trouble. Oh, what would that be? Thanks for the follow, Julia Ratz. I think I remember that from previous years. Welcome. I'm doing part 2 for day 7, and I'm struggling a bit, so bear with me while I struggle here. But thanks for the follow, it's appreciated. I wonder if I can remove like the hit location here, this thing, to process it anyways, but it might blow things up too much. But I can just write this and just move on from there and see if it progresses. What I can do here is, and I need to have my queue. It's no longer beams. It will be this one, Q. So this one will be the current, like this. And we do q.enqueue, start location, this, and then start location, like this. Okay. Great name. Okay, I'll do it. Pause. I'll just call it pause. That reads better. Current.pause. Okay. Yeah, that's fine. Q.enqueue, and this one becomes let me think. It will be current dot path, and we add 1 to it. Like this. Like this. Hey, Sunco Software, welcome, welcome. I cleared part 1 and I'm really struggling on part 2, so, but always nice to see you on YouTube. Let me see. So I might have to remove this part to make sure that we process more of it, but let's just run this first and then we'll figure it out here. So we can do a console write line unique path to the end blah, and this would be current.path. So string dot join. I'm not really sure what this would how this would help, because we don't process all of them yet, but we'll see. Okay, what are we doing? Q is 0. Wait, what? Yeah, I don't update this one and it never goes that way, so that is fine. I should probably do this. Like that, okay. Yeah, I know, but this was just the first way to get it there. So these are that. So if we remove, that's what I was talking about, from we might need to remove this one so that we don't deduplicate that path. But this still isn't 40. So this isn't, this is just path to the end. And once I remove this one, it will branch so much that it will no longer be feasible. So, and I might need to build a key for that. Let's see. Hash set. Okay, wait, what? Oh, okay. Cool. The thing, no, I was trying to find out if I have a get hash code function to combine items, just to make a unique one. There's a way to combine them, I don't remember. So what I could do is just make sure that we at least just take the unique path there, but then still, if the number is so big, it doesn't matter. So you still need to, I think the way is still to figure out the unique connections and just do math and not just actually run them. But because I think you need to record how many unique ways up you have there, and then multiply that with the new, like every time you do that. Um, Let me think. Because I was trying to say that, okay, we can take the unique, I can just do, it's not efficient, but I can do hash set string unique paths is blah, and then I can just say, okay, let's say string path equals string join. We don't care what the separator is, but it's basically this one. Yeah, current path with beam, like this. And then we say if not unique path, no unique path contains path. You probably can get hash code on this, but yeah, it's fine. Then we do this and execute the other logic. So this one lets us at least stop processing stuff that we've done before. And then does that matter here? Maybe. I probably need to remove this one just in case. But I'm not 100% sure. What does this do? Lakai says, when from top to bottom is too much, always better from bottom to top. Yeah. Let's see. Okay, this looks better, but I don't know if these are all the unique combinations. Let's have a counter. Int C is 0. C console count. Okay, so these are the unique paths. So this is the answer for part 2 for the test case, but I don't know if this is efficient enough for the real thing. We don't need to print it. How much work is this for the real thing? How big is the queue? Very big. 0 is too low. What do you mean 0 is too low? Yeah, I didn't print it out yet. I didn't print out the answer. It's still processing. But yeah, this is never gonna work. It hasn't even been down all the way yet. So this naive approach works for, yeah, Nightmare says you need a quantum computer to run it in acceptable time. Sure. Like, and this was also the reason why I said like there should be an easier way, but yeah. Let's see. Octona says I'd say change your visualizing array to a string array and print the numbers there instead of the pipes, so you're able to see if you made a mistake somewhere. Not sure what you mean. Like this part worked, but it's too slow for the real input. I thought I said no test. I thought I said run the test case. That is true. And then we have the unique paths here. Yeah, I think I'm gonna give up for now because it's not going anywhere, but I'm gonna start looking at what everybody else did and see where my thinking was wrong. But I still think like there should be a way to do it this way and then count the branches and then cache parts of it. So yeah, I surrender. Let's see what everybody else did. Do you accept a hint? I don't think at this point a hint will get me there, because I'm either missing something fundamental or just not grasping it. So I think I'm just gonna look at how everybody else did. Yeah, but Pascal triangle says nothing. I don't know that concept, so I'm afraid that doesn't help. I've seen you say it before and somebody else agreed, oh, that's a good hint, but I don't know that term, so I'm afraid I'm not familiar with it. So I'll just revert to looking what everybody else did and maybe see if there's something to learn there. I'm sure there's something to learn there. Sure, I can Google Pascal triangle, but let's see. Infinite triangular array of numbers where each number is the sum of two directly above it. Yeah, but that's what I said. Like, if you can count them and just yeah, okay. Isn't this what I visualized like an hour ago or something? That was the hits thing that I had. I think that was like before I did this thing. I thought I had the numbers in there. Didn't I print? Let's see. Um, mm, mm, mm. Oh no, I deleted that, right? Um, I had actually a visualization. If I go back in the in the stream, I wrote it because I think I did this one. Um, was it that one? Yeah, I think it was the amount of times a beam could hit there. Let's see. I still don't exactly know how to use this though. Is it like the unique ways? Ah, okay. Smap says, I don't make use of that if it helps. Yeah, I'm not really familiar with this, but it looks interesting. But um, since the, how do you call it? It doesn't have to be structured like this, so there would be exceptions to this as well. So what's this? Hmm. But if this is the thing, then how would this help me get to 40 is what I don't understand. Because no single row here would equate to 40. So there's still other stuff that you have to do to get to that. But that's because of like the mismatch of, like, maybe it's a full row of these with one of these, depending on how deep it can go with the reflections and or with the pattern breakups. So yeah, I don't think this quite helps me as much as you think. Mm. Um, I wonder, like, if even depending on the path that it takes, that there could be a different level of numbers reaching a certain point as well. So I don't know yet from looking at this how we would go to an actual solution for the code here. Um, because it doesn't follow this exact shape. So I think I will still just go and look at what everybody else did and see and try to learn something that way, because I don't see a way to solve it yet from looking at that. But that's just me. But thanks for trying to help at least. Let's see. Beam, non-logouts. So it's a bound check. If we encounter this, we do this. Else you go down. So why doesn't this cause an issue? Because if you would do this, it would return multiple times. Add cache. Here, yeah. Does this make sure that it doesn't do things twice for the same location? Okay. Yeah, that's basically all the stuff that I had to do with keeping track of what we've seen and haven't seen. Okay. So what does he do for part 2? Same thing, except So this is just the finding of the start location, and then this one does the bound check. If it's this, okay, so if it gets to the end, it returns a 1, otherwise this, okay. I need to, what does this, because it will only process each index once, but it will return 1 when it goes out of bounds. Caches does all of the job memorization. Yeah, I know that. I'm just like, the logic here is just, you return 1 if you check a thing that's out of bounds. And you add the values of these, but how do you get there? I need to read more code before I can figure this one out, but I've seen patterns like this before, so there is stuff clicking. It's just, let's look at what SMAP did. Might be easier to look at C# first. Yeah, Nineberry says the result of the function is the number of different paths from that. Yeah. Let's see. This is just traversal. Boom. Start, sure. You start below the start thing. Let's see, row index. Let's see, a cell is splitter and previous row is beam. Oh, you upgrade here, so you recreate basically like the drawing. Sure, okay. So this is just basically to draw it there. Minus more grid base, yeah, sure. Let's see what you do here. Let's see, if current time is 0, continue. Wait, timeline counts. Okay, you start below, you set it at 1. So here you... Okay, why don't you just start it at this location then? But let's see. Process everything down. Let's see. You skip the ones that don't have a count. Do the Nexel thing, the splitter. If it's in bounds, current timelines, sure. Let's see. If it's inbound, next one. Where do you increment it? What am I missing here? Because I never see current timelines incremented. I can see you add it to what's there. Ah, okay, the second time that you hit there, sure. So if you hit one that's already 1, it will add, like if it's this one is 1, it will add it, okay. Yeah. Okay. Not 100% sure I understand it, but something tells me like you iterate over it and then it will just increment it once. It will take what it has and then add it. Yeah. Because if you have that will be 1, and then the second time you hit it, that will becomes 2, and you move 2 from there. I think that makes sense. Let's see what Amarte did. Look for the splitters. Okay, wait, let me restart here. Line a span, start column. Mine is very solo mode, just didn't do the full grid. Okay, let me see. What is next thing? Next, okay. Yeah, that's a Pascal triangle idea. Okay. Probably need to remove the word no from, no wait. So we can just let the beam travel. Active call 0, there's no beam, no beam in this cell. Otherwise there will be a value there, but if it's not a split, we can just, okay. Wait. Wouldn't this just set hard 1 to everything? Thought you would need to carry that over. This is part 1. Okay, never mind. Okay. Let's see, part 2. Yeah, okay, so this just keeps. Mm-hmm. Peter is got it, yeah. Steve says, how's today's solution coming along? Horrible. I did part 1 and then after a lot of struggle I wrote something that does the test case for part 2, but it's not not a solution for part 2. So people try to help me with pointing out Pascal's triangle, but that still didn't click enough for me. So I just gave up for now and started to look at what everybody else was doing. So I'm trying to read everybody's code now and just try to see. Yeah, this takes that and then. Yeah. Struggling as always, actually. Let's see. Steve says binomial coefficients and the combinatorics horse they rode in on can die in a fire. Stupid combinatorics, always making things impossible. Yeah. This is far from my forte, let's say that. Let me drop this in Visual Studio so I have some highlighting here. This is my code, let's see. No, this is not my code. Okay. Let's see. To check that I grid where Wait, what? Let's see, what did you do? Grid is a dictionary of location and splitter. Are they records that you defined somewhere? Okay, splitter, no, not fired, fired, and beam. Okay, and this is an XY. Okay, let's see. Parse input. Not fired. Beam. No, okay. Steve says, I think the real solution for it is to create a separate universe with independent time so I can run my solution that takes a few trillion years instantly. Yes, I approve. Let's see. Splitter, parse input. Okay, let's go back to part 1. So this one meant it was the, was this a start? Beam was, okay, beam was start and not fired as a splitter. Okay. Let's see. So this one checks for a splitter. This one finds the start. It adds it to the queue or the hash set in this case. Let's see, splitter. Then it updates it so that it doesn't process it again. Let's see. These are the left and rights. Okay. Okay. Yeah, sure. So you keep track of which columns on the next row to check. Yeah, it took me a bit to figure out, but I got it. Okay, so you update your grid to basically visualize that part. Um, mm, 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 mm. Okay, sure. So this one will do that, okay. Then you check everyone that's sure. Part 2. Let's see. Do you have possibilities? So you zero out the whole thing first. Okay, so you check both those that have been processed but haven't been processed. You update them. Isn't this a hash shot? Oh, it's a dictionary. Wait, what? Okay. Sure, you combine the values of the things in there already. So both of them. Okay. So far, I think it's all been the same solution, right? Let's see. Yeah. Oh, they are both. This is nice. This is part 1 and 2 in one loop. What does this do? This is why is it shifted over one? Because this is because of the input, because they only occur on the odd numbers. So that's funny. Like there's always one in between. So he looked at the input, saw that the beams only occurred on on the even numbers here, while starting at the first one. So this would be row 3, right? Y is 2. So, and then every other one. This is funny. I think this is the first time I've seen somebody abuse that info about the start position. So, to not do any unneeded stuff. Because I just go one by one But basically, you can always do 2. If this works, that means that you can skip half the operations there. Steve says, I absolutely abuse that fact. Nice. Yeah, this is a nice optimization. So for me, that would mean that I can do, like if I do the down one, it would just mean I can do down instead of that one. That would still make part 1 work. Blowfish said, I tested the fact that no there occurs in between. Okay. Nope. Yeah, that works. Nice. Didn't thought about that. So that's a nice one. See, and that's why I really like people sharing their code with me, so I can look at that and realize that I'm not doing enough. I seek over the outlines in the file stream, so it never bothers even reading. Okay. There's always levels to something. Let's see. So let's see. What's happening here? Hmm. Why does it reset the middle one to 0 here? So like the left is get incremented, the right one gets incremented. This one gets added. Feel free to add some context here because I should make my sound less hard because it got a jump scare. Thanks for the follow, Inni Jason. Welcome. Squid Plays on YouTube says, bro, I just finished part A. Well, congrats, you did better than me then. I haven't finished part 2 yet. I'm just looking at what everybody else did to learn something here. Splitters block beams completely, so always... yeah, true. Good point. Yeah, they block that point. Yeah, okay. So where is this initialized? Let's see. Span views visited. Let's see, what was that visited? Yeah, okay. So you start there, you put 1 inside of that. You take the current values. Yeah, okay. Yeah, that makes sense. You set it to those and you add it there. Why? Let me think. Oh yeah, so every time you hit a splitter, you add the counts. SquidKid Play says I use DFS and caching. Yeah, I saw like the Python solutions were nice, nice and efficient as well. This one looks nice as well. it's the same as everything else I've seen before, except the like the. I wonder how the can't even speak. How the Python version would look um, in .NET or in C Sharp, because it's somewhat similar to this, but not quite. Like these crazy. This one. Like. So the thing that's weird or hard for me to understand is like it returns 1 whenever it goes out of bounds. Nineberry says my solution is like that Python one. Come up. Okay, looking forward to seeing it. Because I'm having I sort of understand what's happening here, but I don't quite get how it starts summing this up. Oh yeah, because this is 2. Yeah, this is 2, and then yeah, never mind. It can. Smap UK says it can only go out of bounds at the last stage at the bottom. Yeah, that's true. Or if it would split off, like if it would be right on the edge, but the input doesn't have that. So it returns 1 at the bottom and then just caches its way back up there. Like I could write this in C Sharp, except like the way it works is still eluding me a little bit. And that's probably also why I really struggled with part 2. Let's see, what else did we have? Where did I end up? I end up here. Yeah. Oh, I didn't mean to remove that one, and I wanted to make sure that I added one there as well. Even though people think it's abuse or cheating if they add the cache parameter, but well, that's itertools benefit there. Let's see, Nineberry. After we could just use part 2 instead for part 1 and count the distinct splitters we encountered during the algorithm, but we already have this code that runs fast and gives us a nice visualization. Okay, sure. Flow beam. Okay, cool. Do you have a video of the... I might have to drop this into code and see the visualization. Let's see. Count timelines. Sure. Map.flowbean, safety output name, count activated splitters. Okay. Count timelines. Let's see. If tile is that, sure. This is the first mapping. A queue. We demand a heat map. I actually wrote that as part of the stream earlier on. I had a little thing that showed how many times it hit for the test case at least. But that was a very inefficient thing when I was trying to debug something. Well, try queue. Don't go below map. Sure, bounce check is already been. We don't need to continue. Okay. Get neighboring points. Direction down. Sure. Long traverse timelines point. Let's see, if timeline scales, current point out, long cached. Okay, return cached. Long result is 0. Current point result is 1. Okay. So if we go out of bounds, our result is 1. Let me just see what's happened here. Yep. Let me just quickly answer my wife in between. Blah, 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 blah. Yes, and I answered her in English to a Dutch question, but no, no worries. Let's see. Script lazy. I was doing 4 and kept trying to do optimize, but then I saw people just brute forcing it. Okay. Yeah, that's basically the it works with the cache. Let's see, splitters contain current point. Traverse timeline. Result is, yeah. What are no issues with a Stack Overflow? Like, how deep does it go? Steve says, "Oh no, the terrible English is ruining." No, no, it's just like when I'm streaming and talking to you in English, everything in my head goes in English. So when I have to answer somebody, it's hard for me to switch back to Dutch. But she understands. It's no worries. Library says, "It only goes as deep as the number of rows in the input." Yeah. I don't know what the max stack is currently. What's the max stack depth for C# .NET max stack depth? Okay, I don't even know. Steve says by default it's a wannabe, but can you make a 2 track? Okay. Let's see. There are only 107 so okay. Let's see. This one does this, but if this point is seen, it gives not that. Sure. Neighboring point. Sure. Yeah. Okay. Okay. Yeah. This. Okay. Because this basically defers a resolution until it reaches the end, and then it bubbles back up, and yeah. Luke says, let's see. See all of you guys and girls tomorrow. Have a nice evening. Yeah. Bye, Luke. Thanks for keeping me company, keeping us company, and sharing your code as well. Talk to you tomorrow, probably. Yeah. And this is okay. Yeah, and this is actually because I'm pretty sure we've had this exact type of problem, like the unique path thing, multiple times before in AOC, and I remember like this pattern, but I just never never wrote it myself. Probably, I think this has probably stumped me before. So if I would do this, let's see. The basic way to do this Steve said, I did not opt for DFS approach for this one. Yeah, but I think it would be the way that I need to do. Actually, blah. Let me just commit this version. Non part 2 works only for test. I think this was the one. Just for posterity. So the way to do this would be, let me see, what did we do? You had a queue of grid location. There was a dictionary of grid location, long value cache this. Then we said I had the queue only for part 1. Part 2 uses request. Yeah. I'm just like thinking, like, is this the way that it works? Because it's still basically a lot of this stuff. Right, this is q.dq. Yeah. Why do you keep? I keep typing Bream instead of Beam. So I think. Do I need to have this one already or not? I'm just trying to internalize it and like I've read so many solutions and I'm still struggling with it. That's funny. Let me just, I need to put in the caching stuff in here as well. Because basically, like here would be my, we've reached the end, reach bottom. So this would give you the one result. So would this then be like value cache at add beam 1? Um, this would be like if value cache, try get value, beam out value. Amate says method cache.fody looks to be equivalent for cache.net, but it's somewhat old. Maybe there are other more. Yeah, I want to just I wouldn't resort to that. I just prefer to write it then myself because that means that I learn something. I just need to like the equivalent concept. I'm trying to write it with a Q, and I wonder if that's it. It should be possible, but I just need to cheat a bit and look at. I want to look at this one again, just to make sure that I like the flow. It's that won't work. No, it will work. I just need to make sure that I assign a value to each. So I need to make sure that I also track the value here. So it will be plus and then long val, and I need to do enqueue this like this. Sure. Writing manually is not hard. No. Steve says, I would never stoop to such a level. Yeah. That's one of the things that I always do. I always, or not always, but I often just write it myself instead of using a library for something, just because I prefer to have more control and I learn more from it. But writing cache is simple. Yeah, that's true, but I don't learn as much from that. Let me see. This is just annoying. Next is this. No, it would be like this. Boom, 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 boom. Try to get beam out cached. If this is the case, do we even care? No. Yes? No? Smap says, so the next step is to write the source generated queue to generate cache. Yeah. There's a queue that try the queue too. Yeah. Sure. This only needs to happen when let me see. Do I need to I want like writing this as a queue is messing with me as well. Like figuring out how to what the process would be. So I think I could just Would you queue that one? No, you won't. You don't need to queue it if it's already cached, right? I'm still struggling with this. The logic and transform it. Like copying this logic is not that hard. Famous last words, right? If we just take this, you would have like long get value, grid location, pause, and then you do static. No, I can just do a dictionary, grid location, long, cache, blah. So you'd have if pause.row larger than max rows, return 1. If split location contains pause, return get value pause.left plus get value pause right. Else return get value pause down. This is the basic. This is the basic equivalent of this Python code here, right? Let's see. Steve says the smart solution is to write C# that shells. Actually, I've done stuff like that before. Not for the cache, but just because I needed something that was hard to port. So yeah, I've done something like that. Launch other languages. So this is basically the same, the equivalent to this. And now I wonder, like, if I would write this as a queue, how would this work as a queue? Is the thing that I wonder. So you'd have queue grid location. Q is blah, q.enqueue pause, while q.count larger than 0. Grid location p is q.dequeue. If p dot row larger max rows, can we return? Does it work like this? No. Because you can't return 1 here. So you have to like have a running count. So you would have like long value is 1L. So now I'm wondering, can I even properly write this using a queue? No, you probably... Is there a way to write this as a queue instead of a recursive function? And what would that way be? Because you can't defer the value till you reach the end this way. Like, the whole reason this works is because it won't start combining till it reaches the end, and then it goes fully deep and then zips up. So if you write a queue, you can't do that, I think. There's always a way to rewrite it, but might be painful. Yeah, and that's why I was thinking this. Nightmare also says every recursion can be rewritten as a queue, but can it in this way? So what would be the way to do it? Because you probably need to keep like a stack of all those values and then bubble them up or something. What would be the approach to rewrite this as a queue? The thing about this recursion is that it can only start doing its thing once it hit the bottom. So instead of, it would actually... You can just imitate the stack in your program. Yeah. I'm just thinking like, what would be... Yeah, what we could probably do is just queue up all the values and keep going till we can hit a cache. But but can you unwind it then? No. That is actually, I can't figure how I would write this as a queue. That's probably also why I got stuck trying it there. So, challenge for the Discord. Nineberry says you just have to use priority in the queue so that it's depth first and not breadth first. Yes, but that would mean that you probably you can't use the cache then, because you can't start resolving things till you hit the end. And I'm not sure. Wait, first let me put this here and see if this actually works. P2 is get value, start location. Last in, first out. Wait, what happened? My code didn't work. That's nice. Let's see. You see what I did here? It seems like I'm getting tired again. I'm starting to do really stupid stuff now. Sorry for that. Okay, so yeah, this works. Man, just to think that this is the answer to part 2 is just like, Looks like my code is probably not correct either. It's at least very slow. Why don't I even hit the cache? Ah, that's funny. Bum, 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 bum. If cache try get value pause out long val return val. And I also actually I need to make sure that I cache the values here so that I don't do it. Let's see. You can do the brute force recursion, test it on task. Okay. Yeah. Let's see. Let's do long result. Out result. Okay, let's do this. Oh, Stack Overflow exception. Okay. If else cascade is not correct, let's see. This just propagates it down till we get a result. You do the else event if the first event is if it's true. Override it. Wait, what? I'm missing something, I think. Let's see. You do the else even if the first if is true, overriding that. Ah, sure. Yeah, you're good catch. Yeah, that's a good catch. Like I said, I'm making stupid mistakes already. Is this better? Okay. That's a big number. Thanks for catching that. Let's see if I can get the second star, even though I don't deserve it today. And it works, of course it works. Okay. Let me just, actually I can just put this here. Let's see. Well, Steve, I'm not sure I deserve it, but at least I got a working solution now, and it's a very simple one that I, for the life of me, just couldn't work out myself, which is annoying. So thanks everybody. Amarte says, "What do you mean you don't deserve it? You got it, and it takes skill to reason about other code and apply to it." Okay. Blowfish says, "To be fair, I wouldn't have been able to do it this way. I didn't see you vibe code anything you deserve." Oh well. Yeah. I just, I always feel a bit disappointed in myself whenever I can't solve something straight away. Let's see. TV Josh said, "You did the beams problem. What did you cache?" It's basically, is this depth? This would be depth first, right? Basically, it's just what it does. Yeah, it used the map too. Okay. It will just cache out the values to go over a lot of iterations. I'm not even sure that I can properly explain it, but TV Josh said, "I did a BFS level first." Blowfish says, "Please have a look at my solution. It just caches the previous row, then forgets it." Okay, let me see. Did you just post it? Yeah. Oh, let's look at it here. Convenient, but bloats expires. Okay, back to printf. Yeah, the thing that I kept harping on was like the way of counting from bottom up is actually what the algorithm does, because it goes to the bottom and then starts adding it all together. But I couldn't get to the solution myself, so. But yeah, let's see what happens here. Text files. Is this a macro? Let's see, I split count. Thanks for the stars map. Let's see. So if the one above it is like a marker or a beam, and this is a splitter. So this one just updates the map and marks this a dead stop. So this takes care of not going through the same thing twice. Let's see, Steve says it's also good for SMID and cache coherence prefetching, eventually doing all row by row. Okay. So split and otherwise just propagate down. Print lines, split count. Okay, yeah. So this was the thing that I did wrong in the first part, to just keep processing it. And I used like, since I don't use the full map, I use sparse maps and just a hash set to keep track of what I did and what I didn't do. I could probably have just removed that every time I process it, just remove it from the hash set so that even the lookups become faster. But I try to never do really destructive things there, but that would have been a nice way. Let's see, Laurent says it's memory optimized DP as you only need the previous row. So it's ON instead of ON, okay. Yeah, I see multiple people looked at the same, basically, to just keep track of which columns you want to process and then just go row by row. So yeah. let's see, 1, 2, explicit cell, non-accept. Okay, marks explicit. Okay, what does this mean? Cell say no accept, marks explicit. Okay. Is this to allow a certain type of conversion to happen? Sure, this one gets the first array. Oh, I need to stop doing that. Let's see. And place backline. Okay. Skipping lines for speed. Yeah, we've seen a few people do that. It's nice. Let's see. We know it's a tree might include a loop from center. Okay. Inherit visit count. Okay. Yeah, and this will also just increment based on how many times it sees it. It will just keep adding. This is the Pascal triangle way of doing it, right? Well, how would you like the Pascal triangle thing? Let me. Do I have a tab open with it? It's not quite that, right? Because it will just. Will it merge? Yes, it does merge those two. No. So it's not based on that. It's not quite that. TV Josh said, I wouldn't have thought that skipping the empty lines would make much of a difference. Yeah, it's just extra operations that you can skip. It's a small optimization, not a large one. So I also I saw somebody on Discord do that. Yeah, like this one triggered that for me to realize, oh yeah, you can just skip every other line because they are indented like that. So that made me go in my code, instead of going down, I just do down, down. And then you don't have to do all this. You can skip a bunch of lookups that way. So yeah, it's a nice optimization. It's not the biggest one, but it's quite a lot of ops that you can save from that. Let's see. The optimizations are for your soul. Yeah. Well, I find I like that I'm able to do. It feels good, like when you can be smart to fix some of those things, right? Um, but doesn't the code immediately see that there's no splitters on the line anyway? Yes and no, but still you have to check. Like if I do this only once, then I have to do. In my case, I use a sparse map, so I have to make sure that I do a lookup in the hash table to see if one exists at that location. And using the actual text-based map in this case is probably more efficient because you can look exactly at a spot that you expect to see if it's there. So my sparse map is probably less efficient. I know it's less efficient. I should have probably just scanned for the start location and then do exact lookups, because that is faster than checking if an entry exists in that hash table. So a lot of times it's useful to have but in this case I'm pretty sure it's faster to just look at the raw value, since you know exactly where to look. Boom, 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 boom. So this is basically like this approach, and I've seen a few people do this, is you don't actually branch out, but you just make sure that you keep track of the values, so that you do process the splits, but only everything you do at once. So you don't make sure that the beams individually only happen once, but you do that multiple times, so you can get the increased numbers. And then you propagate everything down. So I think this is also quite a clever approach, and probably more suited than, or more topical than just the cached search. But like wrapping my head around, I should probably also write this just to internalize it and learn from it. Let's see. Nineberry says it's fast enough for the teleporter. It's fast enough to fix a teleporter and get on with the decorated normal. Yeah, that's true. So like if I look at basically this version of the logic, is if I compare it to like the part 1 code, it would this one would still be the same, because you don't process the same splitter more than once, but this one would need to be removed. And we would need to keep track of the values there. I wonder how I would write that. This one would take it down there. Yeah, within the size, yes. So I wonder if I would do this like a part 2 alt. Steve says, I got mine to a place where it runs about in microseconds, okay? And it can take about 15 microseconds if I only read the file and do nothing else. Okay. So reading the file is the biggest job there. Profius Fugu says, passing down the visit count line by line, in the end adding each path together. Yes. Yep. So for the final result, you need to take the ones. Wait. Oh yeah, you take the last row there. Yeah, you take all the beams that end that reach the bottom, and you add those up. Yeah, that was basically the idea that I had here. What at least what I was trying to do, like get the calculations and then. But I never got around to solving my version. I need to put this into the code as well, actually, uh, just so that the test completes. Yeah, I wonder if I'm gonna uh, write it another way, but it's already getting a bit late, so maybe not now. So yeah, I think we'll. Did I check everybody else's code? Um, no, I didn't. Two more, I think. Um, no, I just checked this one. And here is Steve's code. Skip take a look. No, I like F sharp. Did I miss it? Sorry. Uh, no, wait. Am I skipping something here? I'm sorry. Marta said, could you share your CPU model? Mine is 42 microseconds on my slow i5. You're going for the crown, Amate. Let's see. Yeah, I think I got to here, so I need to. Uh, yeah, my bad. Sorry. Yeah. My bad. I will go through them. I should probably mark every one of them next time so that I make sure that I don't miss any of them. Um, let's see. I like F sharp, at least reading it. Match lines with this. Splitters that add and then to ignore. So why does it like it goes on to ignore here, but here it's like an empty lambda kind of thing? So I can see the explicit discard and the implicit. Well, this is more explicit where you need to do nothing. This will ignore everything that doesn't match. Ignore is just to avoid the function to return. Okay. Okay. Match lines RC with this. RC. It's funny that you do the length -1 to get the actual max row, so you can probably use that later. And then here you you plot one them again because you have to have the size for the init there. Let's see. Recursive count split times. It's out of bounds or nothing. Let's see. Count split times. To try, to try your start position or to try the queue. Destructive position, row columns. If it's below max column, sure. This is the path down. If it hits a splitter, this is basically the same logic that I see here. Visit. So I see like this is the walking part, but I don't see the actual logic here. Never mind. Like I said, it's getting late probably. If you if you hit a splitter, you track it and then you see how many times you see it. Never mind. Let's execute. Okay. Mapping. Slow naive. Okay. Can timeline splitter. Let dp array create max goal plus 2. Okay. Is this like an enumerator create thing? Func row sequence one. A splitter contains row. Sure. Don't understand this or this, but let's see. I go from bottom to top, and if I found a splitter, I add both sides. Okay. Yeah, I just wonder like this sequence thing, max row dot dot minus one dot dot 0. What does this do exactly? So what would this produce? Because max row is like the length minus 1, right? Didn't that... Yeah. So this is rows minus 1. Start value, step, and step. Oh, okay. So it goes here, it goes down 1 till it hits 0. Oh, okay. Okay, nice. So this is yeah, okay. And this one is inclusive. Okay. Nice. So and here you go the other end. This is the, never mind, this is rows, this is the columns. Why does it start at 1, not 0, and it goes to the plus 1? I thought it was it's not inclusive? Because if you go to max call plus 1, wouldn't that be out of bounds? Oh no, you did. Cannot come from null at the bottom from, because I cannot come from null at the bottom from 0. Okay. But this is the columns, right? Ah, okay, you can, sure. So you start at 1 because you do minus 1 here. So you only check to the left of the, okay. Maybe I'm missing something here. But I understand that you start at 1 and always check the value -1, so that would mean you only check the left part then? Hmm. Why I'll just jump over it for now. I'll do some F sharp research in my own time. Um, but this looks like a column, just like the value shifted 1 over. And I can see that you do like -1 here, but then wouldn't this be out of bounds then if you go to max call +1 already? So this can all be 1 out of bounds, and then you go another 1 out of bounds. But that's probably something that I'm missing there. And where was the memoization? That was the DP thing, right? So don't mind me. I'm just having a bit of issues trying to understand everything. But let me move on to the next one. I always like looking at the F sharp code though. I should probably try it sometimes, but uh, let's see. I just checked this one. Sure, logic is in the solver or in the this one here. Let's see. Beam and splitter. Witness the power of spanty. Yeah. Let's see. It's a weird distinction that C sharp spread end is non-inclusive and F sharp the end is inclusive. When you use DP, you usually add an extra row or column or both to the existing grid. Okay. Steve says, I also have issues with understanding everything, so I gave up and now I understand nothing. I did that. Have you achieved nirvana? Yeah, it sounds like it. It sounds blissful. Let's see. Split beams. Um, a helper to create a 2D grid from the string. NAS. Grid span is S span to D. First row, get row span. Set first beam, first row. Okay. You had constants for the other two. Why not for the start marker? Let's see. Part 2 is beam timelines and not propagate beam. Okay. Propagate beam. This is part 1. Look through the rows. Okay. If toggle is beam is yeah. Lazy and I didn't want to check for S if it only appears once. A waste of my precious if statements. Yeah. Let's see. Beam. You could shift these over probably in the loop instead of getting them both explicitly. I don't know if it makes much difference, but so get row, so it gets you the span of that row, get row and get column given enumerator. Okay. So you just check. If it's a beam, check below it, right? Propagate the beam if so, otherwise we split. And how do, oh yeah, you only go down there. Mhm. I'm just thinking like there was something that we needed to do to prevent something from happening twice. Um, mm, but since you just yeah, okay, you just zip over the map, you don't actually do a follow, so that was why you don't need to account for that. Yeah, makes sense. Other was beam timelines. Let's see, long grid, span, count span, get row, so beam break. Wait, what? Never mind. You put a beam where the S was there. I was like, am I missing something? No, okay, yeah. You altered the grid, so now we're looking for something else. So this is basically just finding the starting point again. Set the value to 1. To the rows, yeah, same way of going there. Count span, yeah, that's a tracking of all the values. If it's not tracking anything, we don't need to bother with it, so we continue. Otherwise, we get that value. So you could probably like do this up here and then compare this against 0 so that you don't have to have the same thing twice, but it doesn't really matter much. If current call, basically counting grid, yeah. If it is a splitter, you add the current count to those. So this is either 0 already, or it will increase, it gets the current value added. Yeah. It's pretty clean. I like it. I should probably also write this version, but not now. I noticed that I'm getting uh, I need to first rest before starting to code again because it's been a long day already. But this is clear and clean and easy to follow, um, and I think like this is the way it was intended to be solved by Eric. Like this, at least I think so. Kind of feel like this is cheating a bit, but it's good to know nonetheless. Um, and actually, this is the way that you would write it when you do it with a queue. Um, so yeah, I'll just add this to my to do and take this one with me. So yeah, and then you take all the ones from the last row, add them up together, and get the result. Yeah. Steve says, I've been trying the strategy of resting whenever I'm unable to solve a problem. It's been a few decades now, but any day now I might be done resting. Yeah. I like your humor, Steve. Never change. Yeah. No, but like it usually helps. I've had previous years when I was stumped by something in AOC, and I just like, after 4 hours of struggling, I was like, okay, now I need to just do something else. And I go to sleep, and I wake up, and I've had a few times where I was like, bzzzt, and code is done. Just like having time to not actively work and think on it. Uh, yeah, it sometimes helps. Not always, because there's plenty of times where I just couldn't like visualize a solution. I'm not sure. I don't think that the one for today, uh, it would have worked like that. To just go to bed and then wake up in the morning and it's like do it like, oh, that's the way I should have done it. But The thing is that just this way of counting unique paths, I'm so sure that if not last year, it was the year before, there was a problem that just had this exact way of doing it, and it just eludes me. Um, so yeah, it was also with like branching and um, yeah. Let's see. I have so many tabs open. Let's see. Did I get all of them? No. Oh, this was Steve's, right? No, no, I haven't. Was it? Yeah, this was Steve's. My bad. Uh, I started at this and then aborted. I think. I think I got scared and ran away. Um, let's see. Okay. Splitters. Shift buffer. Middle shift buffer. So what do you do with these buffers? So I can see like it skips one from both ends. This one just uh, skips the last two. This one skips the first two. What's happening there? Tensor primitives. Good lord, yeah. Steve is the king of optimization. He tries to squeeze. It's a sport for him to just squeeze every last bit of performance out. So Steve said, I got hit with an ad immediately, so I missed any question you had. Oh, sorry. I said it like so that you don't get any ads when you have to pick an evil on Twitch when you're an affiliate. Sorry for that. So I always make sure that you don't get an ad when you start viewing, but they just randomly insert them. So I was asking about the shift buffers. Um, what's the reason here? I see it's you take the width, add two. This one skips one from either side. This one skips two from the end, two from the start. But what does it do? Shift buffer 0 equals one from the back. So you set 0 to the first and the last one there. Why is 3 positive line length? You made it width plus too long, so you can read one as it's left shifted by one and one as it's right shifted by one, which emulates a split. Okay. Still not sure. I'm gonna read everything and see if I can figure it out. Read both. So this takes the data in there. Right shift 6. Okay. Okay. Yeah, this is way above my head. I can't figure out what I'm reading right now. I'm not familiar with these. Let's say taking the bytes from the input file and right shifting by 6, make it so there's a 1 where you hit a splitter and a 0 when there's not. Ah, okay. Okay. How did you even get to that? That's nice. That's funny. So you abused it to just map out. Okay. I just look asking various. Yeah, yeah. Funny. Steve's code is like cephalopod math. Yeah. He said, I did it often enough for problems like this and get meaningful data without branching. Yeah. Yeah, this is way above my pay grade. I love looking at it, but I don't even timeline count. Beams that sum. Funny. This is like something that I would have to study to like really comprehend every step. Where do the beams even get set? Beams are clear, beams are... okay. Ah, here, okay. Device and... okay. It looks really cool, but I have a really hard time doing this in my head to comprehend it. But I'm always surprised to see what you come up with. It's always it's for me always impossible for me to predict what kind of code you come up with to solve it, and I'm always amazed. But I really like looking at it. Marta says, well, I know I won't be able to beat this speed, so now I try to make each day 0-byte heap allocations. I have 3 problems to go. Nice. Yeah, find your own challenges. It's fun. That's also why I really like the visualization stuff. It's always something that you can do. It's just whatever brings you joy, right? Like this is Steve's jam. Finding cool ways to solve the problem and get as much performance out of it as possible. In general, I'm just happy when I can even finish a day without having to give up and having to get help in this case. So yeah, I'm really looking forward to see what else people on my Discord thinks is an easy day and I'll struggle. So it's 2 for 7 so far. But yeah, I've learned something new again today, and I think I will go back and change some code, maybe write some other things. And see, Steve says, none of my solutions this year do any allocation for the actual solve, but the framework makes an instance of a class for each day. And there's some string path manipulation to generate the input file. Sorry, I don't have, I'll create a link. Here is this. Hello, Julio, welcome. There's a link to the Discord for those who want to join and share their code as well. And Marta said, I made that Viz stuff to allow me to look around the maps and everything that you saw a few days ago. Sadly, Eric didn't give any new challenges that would need Viz. Yeah. I like the one that you made for me. So yeah, welcome everybody. It's nice to have you in here. I think for now we'll end it. So sorry, Julio. We're just about to close. I just want to go see if there's somebody else still doing Advent of Code, so that we can go and say hi and spread the joy of coding to somebody else. Let's see.
Like this.
Let's see how they're doing.
Yeah, this block is obviously unused. Can I just do that? No, I do need an expression there. That's a little bit annoying. But
is this still Advent of Code?
Yeah. We're gonna get rid of this big statement in a minute.
Okay, so I think we're gonna rate. Let's see. We're gonna rate this person and gonna and spread some of the AOC joy. So, Julio, I'm sorry. I'll stream again tomorrow, so feel free to join us then. And meanwhile, you can share your code during the day. Other people will do that as well. So that's a lot of fun, I think, at least. So for now, thanks everybody for joining, and let's go share some of the AOC love with Funny Boy. So yeah, thanks, and hopefully see everybody tomorrow. Bye bye.
This. And then we don't need to do this. We can say count plus. No, we don't even need that. We can just do that. Not quite that. Oh, thank you for that.